Hey class, in this week's discussion you are asked to discuss the linear and quadratic functions. You're asked to find the domain and ranges of both as well as the optimal value for the quadratic function. So let's just give an example of a linear function. It has the form y is equal to mx plus b. Okay? So you can imagine the m is the slope and the b is the y-intercept. So you could replace this with something like y is equal to 2x minus 3. One of the easiest ways to find a domain and range of a function is to graph it and see where the graph extends. So if I only have an equation like this, to get the points to graph, I can just plug in values, at least two values, and connect the dots. So what I like to do is plug in the value when x is 0. Okay, so when x is 0, you have y is equal to 2 times 0 minus 3, which is negative 3. Okay? So we know that 0, negative 3 is on the line. And we also know, in this case, if I plug in x equals 2, let's say x equals 2, y is equal to 2 times 2 minus 3, which is 1. We know that the value of 2, 1 is on this line. Okay. So if we look at our graph, and I have to go over, down 3, and there's a point here. I have to go over 2 and up 1. There's a point here, and then you just connect the dots. Okay. So it should be clear that in most cases a linear equation extends in all directions forever. Okay? So you see it goes from negative infinity to positive infinity for the domain because it ranges all the way across this way, all the way across that way, and also from positive infinity to negative infinity this way. So the domain and the range of these two are all real numbers. Okay? That basically says domain's negative infinity to positive infinity, range is negative infinity to positive infinity. But let's remember that value. Y is equal to 2x minus 3. Okay. So again, we have y is equal to 2x minus 3. The question then is domain, range, we have that. Don't get that mixed up with the root of the solution of the equation. The solution of the equation is found where y is equal to 0. So if you plug in 0 is equal to 2x minus 3, and then take over to 3, let's see that x is equal to 1.5. So 1.50 is the solution to the equation, but it does not tell you anything about the domain or the range. Okay? Now, having said that, some linear functions are in fact bounded. Okay? So that means their domain and range are not all real numbers if you have a bound on your x values. So say, for example, we're looking at this y is equal to 2x minus 3, and we're letting x equal the number of widgets that were sold. Okay? And for some reason, we could only purchase, so we only made 2,000 widgets. Okay, that's all we have to sell. You can think of y as your revenue, okay? And you can think that the minus 3 is our fixed cost of doing business. It cost us 3 units to start production. In this case, the domain, which is the number of widgets possible, is 0 to 2,000. We could have not purchased anything or not made anything all the way up through 2,000. Okay, and actually these should be brackets because you can be at 0 and 2,000. That means that the equation that we had, which looked like this, okay, only exists from 0 to 2,000. Okay? So once you bracketed the x values, there is by definition a bracket of the y values, which ranges from here to here. Okay? to find those brackets, you just plug in the limits and solve for it. So at 0, we already saw that at 0, y is equal to 1.5. Oh, sorry about that. That is not correct. We solve for y is equal to 0, not x is equal to 0. So at y is equal to 0, we have y is equal to 2 times 0 minus 3, which is y is equal to negative 3. So the lower range of your variable of your equation is 0, negative 3. Once again, y is equal to 2x minus 3. So at 0, you get y is equal to negative 3. At the top range, we have 2,000. So you can plug in 2,000 minus 3, which is 4,000 minus 3, which is 39.97. So in terms of the amount of money you'd make from selling these widgets, we see that the domain ranges from 0 to 1,000, but the range is bounded by negative 3, which means you lost the amount to start production if you don't sell anything, to 39.97. And that is how you would analyze or interpret your discussion for the linear equation part. Now let's turn our attention to the quadratic equation. So as you know, the quadratic equation has the function y is equal to ax squared plus bx plus c. Okay? Do not confuse, well, before I say that, the thing that makes this a quadratic equation is the fact that you have a squared coefficient, and that's the highest coefficient you have. So this 2 right here lets you know that you're dealing with a quadratic equation. Okay? So now since we know what the actual equation looks like, let's give it some values. Okay, let's say y is equal to x squared minus 7x plus 10. Okay. What many of you guys did for your discussion was to actually solve this using the quadratic equation, which is fine, except that's not what we asked you to do. Okay? So if you think about it, okay, the fact that the a here is positive, in our case it's a 1, means that the graph of this parabola is going to be up. Okay, so the graph is going to look something like this. Okay. Now, if you plug in values at x equals 0, okay, so you have this term would fall out. This term will fall out, and this term will fall out, and you'd have 10. So you know this parabola crosses the x-axis at y is equal to 10. And then it goes up to infinity in each direction. Okay. So then next question is, if you were to solve this, what would be the roots of the equation? Okay. So to solve this, you could use your negative b plus or minus the square root of b squared minus 4ac over 2a. But it's a lot simpler to try and simplify it first, because I'm going to try to simplify and factor first. So if I have an x squared, I know that I have to multiply x by itself. Okay? Now, looking at this positive 10, in order to get a positive number, I have to multiply 2 positive numbers or 2 negative numbers to get a positive number. So then you look at that second number, negative 7. The fact that you have a negative 7 in the middle means that I need to have negative numbers multiplied by each other to get to it. Okay? So think about the factors of 10. You have 5 and 2. And we know you need to subtract them. So if I were to solve this and set this equal to 0, I see that x is 5 and x is 2. Okay? All right? These are your roots to the equation. when you solve them, you end up with y is equal to 0. Excuse me. You end up with y is equal to 0. Now, don't get confused with the root or the solution to the equation along with what's the optimal value. Okay? So I'm going to rewrite this, x squared minus 7x plus 10. So y is equal to x squared minus 7x plus 10. Okay? The solution or the optimal value for this is going to be negative b over 2a and the value at negative b over 2a. So in our scenario, a is 1. Oops, sorry about that. A is 1. B is negative 7. C is 10. Okay. So negative b over 2a is 7 over 2, which is 3.5. Okay. And then I plug 3.5 into my equation, and I would get the value that I'm looking for. So f of 7 halves gives you 49 over 4 minus 49 over 2 plus 20 over 2. Okay. Now from here I can actually put all of this stuff on a 4s. So this would be 98 over 4, and this would be 40 over 4, and this again is 49 over 4. So 49 and 40 is 89, so I'd have negative 9 over 4. Okay, so since this is a positive parabola, okay, the value at 3.5 negative 9.4 is the value that's the lowest on this particular parabola. So you can imagine if you're looking if you're looking at your parabola and it has a graph that looks something like crosses at 5 and 2, something like this. Okay, that's actually a pretty horrible parabola. Let me do a little bit better. Okay, so we know where it crosses the x-axis because we shifted it. Okay, and we solve for it. So at 5 and 2, we know they're roots to the equation. Okay. And at, this is 2, this is 5. No surprise that 3.5 is right in the middle of them. Okay. And at 3.5, I'm at negative 2 1/4, so I'm down here somewhere. Okay. And I know it crosses it at 10. So my parabola looks, my parabola looks like this. Okay. The optimal value in this case is negative 3.5 and 2. Now we're looking for the domain and range here. We see that in terms of x values, it goes in all directions. But in terms of y values, it does not get lower than negative 9.4. So the range in this case is negative 9/4, and it goes up to infinity. So I just wanted to kind of make sure that you guys understood that there is a difference between the root or the solution to the equation, which in this case we found was 5 and 2, and the optimal value. Those are different. Okay. One other thing I want to show you before I get out of here. Okay, so let's go back to a new page. So if we have y is equal to x squared minus 7x plus 10. Okay. If you can find a way to put your function in this format, then you can find what your optimal value is. It's just plain old HK. Okay. So I'm going to try to take our ax squared plus bx plus c and put it in this formula. Notice I need to have something I multiply by to get to this x minus h squared term. Okay? So if I just think about what's in the middle, okay, in the middle I have negative 7. Okay? So if I divided that by 2, I'd have negative 7 halves. And if I squared it, I would have 49 over 4. Let's just say I had x minus 49 over 4. Let's see. How would that work? Okay. Let me erase this. Actually, you know what? Let's just use x minus 7 halves to start off with. That might get us where we want to go. X minus 7 halves. Okay. Why did I choose 7 halves? Because I need to multiply something by itself to get a number, and then make sure that the middle number is going to add up to 7. Okay? So if I have negative 7 halves x, see, in other words, x minus 7 halves times x minus 7 halves, x times x is x squared, x times negative 7 halves is negative 7 halves x, negative 7 halves x is here, and then I have a 49 over 4. So these inside simplify to negative 7x, which is what we have. Okay, but when I do that, not only do I have a negative 7x, but I have a 49 over 4. Okay, now my value of 10, I'll put it back here, I have a 10 out here. Okay, 10 is the same as 40 over 4. Okay, so what do I need to do to get to 49 over 4? Okay, well, 49 over 4 minus 9 over 4 gives me 40 over 4, which is 10. Okay, so once I have my x minus 7 halves squared, if I subtract off 9/4, I end up with my actual value. Okay? So just again, give you another view of it. And so y is x squared minus 7x plus 10. Okay? I got to y is equal to x minus 7 halves, and I squared it, which gave me 49 over 4. Okay? So when I simplify this, I'd have x squared minus 7x plus 49 over 4. Okay? I need to subtract 9 over 4, and this term here will give me 40 over 4, which is the 10 I'm looking for. Okay? But when I bracket it, okay, this is the squared term, so I'd have to subtract off 9 over 4. So in other words, this term here, x squared minus 7x plus 10, equals x minus 7 halves squared minus 9/4. And remember we said that h over k is your optimal value? Well, in this case, h is 7 halves. This is h. K is minus 9 over 4. Okay? So again, we have 7 halves, negative 9 over 4, which is 3 1/2, negative 2 1/4. So you see we end up with the same information. Okay? So that's about it for me. A quick little video just to kind of show you what we're thinking about in terms of solving for an optimal value of a quadratic equation. Hopefully you guys can hear on this particular video. I do live relatively close to the airport, so you may be hearing planes fly back across my front lawn. But just want to touch base with you guys, and we'll be talking to you soon. Hopefully I'll be able to do these kind of videos at least once a week or so, just to kind of round things out for the week. So you guys have a wonderful day. Take care.